It's time to discuss non-terminating recurring or non-terminating repeating types of decimals. Okay, what does that mean? If the process of division never terminates, but some part of decimal repeats an infinite times, such decimal expansion is called non-terminating recurring. And for some rational number, the decimal expansion is non-terminating recurring. Okay, for example, 1 by 3. What is the decimal expansion of 1 by 3? So 1 divided by 3. In 1, how many 3's are there? 0. 0 into 3, 0. Remainder 1. I am giving an extra 0. Whenever I am giving an extra 0, I am giving a decimal. In 10, how many 3's are there? The answer is 3. 3 into 3, 9. Remainder 1. I am giving an extra 0. In 10, how many 3's are there? 3. 3 into 3, 9. Remainder 1. In 10, how many 3's are there? 3. 3 into 3, 9. Remainder 1. And this is moving on as never ending. This is an example of non-terminating but repeating. So look, the decimal expansion of 1 by 3 is basically 0.3333, etc. And one more thing, this is also represented as, here 3 is repeating, right? The digit 3 is repeating. This is also represented as 0.3 bar. And what does this mean? The 3 is repeating. Okay, you didn't understand the representation. Okay, what is the meaning of 2.375 bar? Meaning 2.3 is there, but 7.5 is repeating again and again. 7.5, 7.5, 7.5, and it is never ending. That's what this representation is. What is 7.81 bar means? Sorry, 8.81 bar means 8.818181. It's never ending. Yes, hope you understood the representation. Okay, we have some problem. We have some problems to discuss with, and the problem is express 5 by 9 in decimal form. Let's see in 5 how many 9's are there. There is 0, 0 into 9, 0. Difference is 5. So I'm giving an extra 0. Whenever I'm giving an extra 0, I will give a decimal. In 50, how many 9's are there? 9, 18, 27, 36, 45. So it is 5. 5 into 9, 45. Remainder 5 and extra 0. 50, how many 9's are there? 5. 5 into 9, 45. Remainder 5 and extra 0. So 50, how many 9's are there? 5. 5 into 9, 50, 45. And it is never ending. It is never ending. So basically the decimal expansion of 5 by 9 is 0.555 etc. or 0.5 bar. 5 is repeating. Hope you understood how it works. Now it's time to discuss types of non-terminating repeating decimals. It is divided into two. Pure recurring decimals and mixed recurring decimals. Simple. Pure recurring decimal means a decimal number in which all the digits after the decimal point are repeated. In a decimal number, after decimal point, every digit is repeated. 0.4 bar. After decimal, every number is repeating. This is what is this? 0.444444 etc. After decimal, every number is repeating. 0.32 bar, 0. That is 0.323232. Look, after decimal, every number is repeating. Pure recurring form. 0.675 bar. What is mixed recurring form? A decimal number in which at least one digit after the decimal point is non-repeated and the rest is repeated. For example, 0.645 bar or 0.6454545 etc. This is mixed recurring. Why? 6 is after decimal 6 is which is not repeating. Remaining 4545 is repeating again and again. Another example 2.1275 bar. 7 5 only repeating. After decimal, 1 2 is not repeating, but 7 5 is repeating. That's the difference. Mixed recurring and pure recurring. I'm giving you one more information, not in a non-terminating repeating decimals. The ordered set of digits that repeats is called period. And the number of digits in the period is length of period. Okay. There is some set which is repeating, right? This set is called period. And the number of these digits are called the length of period. For example, in 0.44444, it is the period is 4 and length of period is 1. Only one digit is repeating. In 0.323232 etc. This is there is etc. 32 bar. Here the period is basically 32 or 32 and length of the period is 2. Two digits are repeating. What about here? Here 0.645 bar 45 is repeating, right? So the period is 45 and length of period is 2. Here period is 75. Length of period is 2 again. Have you understood? Okay, if you don't, we have a problem to discuss. Find the period of decimals of 22 by 7 and the length of its period. We can do that. 22 divided by 7. Listen very carefully. 22 divided by 7. In 22, how many 7s are the 3? 3 into 7, 21. Remainder 1. An extra 0 which is not the. I will give a decimal. In 10, how many 7s are there? 1. 1 into 7, 7, remainder 3, and extra 0. In 30, how many 7s are there? 4. 4 into 7, 28, remainder 2, and extra 0. In 20, how many 7s are there? 2. 2 into 7, 14, remainder 6, and extra 0. In 60, how many 7s are there? Probably 8. 18 to 7, 56. Remainder 4 in 40. How many 7s are there? 7. It's 14, 21, 28, 30, 35. Yes, 42. So it is 5. 5 into 7, 35. Remainder 5 in 50. How many 7s are there? It's 7. 7 into 7, 49. Remainder 1. Okay, we got remainder 1 again. And we are getting 0. In 10, how many 7s are there? The answer is 1. 1 into 7, 7. Remainder 3. And look, from here onwards, it's repeating. This thing is repeating again, again, and again. So what is the decimal representation of 22 by 7? The answer is, look, 3.142857, then 1, then 4, then 2, then 8, and it is repeating 0.142857, 142857, 142857, and it is never ending. So basically this is 22 by 7 is equal to 3.142857 all bar. Question, what is the period? The period is 142857. Question, what is the length of period? The number of digits in a period is called length of period. 1, 2, 3, 4, 5, 6. It is a 6 as is length of period. Have you understood how it works? Well, rest we will discuss in the next video. Thank you all.